All right, we are going to take a look at multiplying and dividing rational functions. So to multiply rational functions, the first step is to simplify. So that probably means factoring. So if we look at this first example, all I want to do is take every piece of each of these fractions and simplify. So in this first one, I see I have a GCF of 4x, so I'm going to factor that out. And I'm left with 1 minus x inside my parentheses. In the denominator, I've got x squared, and I have 3 terms, so I'm going to need to factor using some magic numbers. So I need 2 numbers that multiply to -3 and add to +2. So I can choose, let's see, +3 and -1. And then I'm just going to copy down my multiply sign and then do the same thing with the other fraction. So again, I've got a trinomial up top, so numbers that multiply to -6 but add to +1. So in that case, I'm going to choose x plus 3 and x minus 2. And then the denominator here of 4x, I don't think there's anything I can do there. All right, so now that I have simplified, step 2 is going to be to cancel like terms. So I'm just going to look at the tops and the bottoms and cancel anything that is the same. So I see I've got a 4x on top and a 4x on the bottom, so I'm going to cancel those. And then I have an x plus 3 and an x plus 3. And then I've got this 1 minus x and this x minus 1. They look really similar. So I'm actually going to go back to my simplify step and see if I can simplify this anymore. So if I look right here, if I could factor out a -1, I think that's going to fix those signs to look like the one in the denominator. So if I factor out that -1, I would get a positive x minus a -1 over x minus 1, and then I still have times x minus 2 over here. Well, now when I look at this and I go back to my cancel step, I see that those x minus 1s are going to cancel. Okay, now I have canceled everything that's the same in the top or bottom. And so my third step is just to multiply across the top and across the bottom. So multiplying across the top, we just get -1 times x minus 2. And across the bottom, there's nothing in the denominators anymore. So this is my final answer. Trying another example over here, I just follow these 3 steps. I start with simplifying. So I see I can factor out a GCF. So I get x times x plus 3. And then again, I'm going to use my magic numbers. What multiplies to +8 and adds to +6? I'm going to choose x plus 4 and x plus 2 times, all right, what multiplies to -2 and adds to +1? I can choose x plus 2 and x minus 1. And in my denominator, I'm going to be able to factor out 4x squared as a GCF. So I'm left with x plus 3. Okay, now that I have simplified, I'm going to cancel like terms. So let's see, I've got an x plus 2 and an x plus 2. X plus 3 and x plus 3. And I have one x here. This x is like x times x because of x squared. So I can cancel out one of them. Here, I'll scribble it out so it looks easier. So I'm left with just one x there. So if I multiply those across, in the top I have x minus 1. And in the bottom, I have x plus 4 times 4x. And if I double check to see if anything cancels, it doesn't. So I realize this is my final answer. So we can use this exact same strategy when we want to divide rational functions. There is just one step that we need to add first. So the first step is going to be copy, change, flip. So hopefully this is something you practiced in Algebra 1, because if we're dividing 2 fractions, we can copy down the first fraction. So I'm going to copy down. I'm going to look at this example as I do this. 16x minus 2x squared over x squared minus 9x plus 8. So I copy the first fraction. I change the division to a multiplication. And then I flip the last fraction. So I'm going to put what's on the bottom on the top and put what's on the top in the denominator. We can do this because dividing by fractions is the same as multiplying by their reciprocal. So now that we have rewritten this as multiplication, we go back to those steps we're familiar with. So first we need to simplify. So I'm going to factor out any GCFs or anything that I see. So in the first one, I can factor out a 2x times 8 minus x over what multiplies to positive 8 and adds to negative 9. I can do x minus 1 and x minus 8 times 5x minus 5. I can factor out a 5. And then 2x I can't simplify. And then the next step is going to be canceling like terms. When I go to do this, I notice that this one right here is very similar to x minus 8. So I'm going to go ahead and factor out a negative 1 so that I can rewrite this as negative 1 times x minus 8. So I'm going to kind of just scribble that out and have this instead. So now when I cancel, I'm going to cancel this x minus 8 with this x minus 8. I see I can cancel this 2x with this 2x and x minus 1 with x minus 1. Wow, so I've canceled out a bunch of stuff, meaning my last step is to just multiply. So multiplying across the top of these fractions, I have negative 1 times 5, so negative 5. And there's nothing left in the denominators. So negative 5 is going to be my final answer here. All right, trying one last example together. I'm going to copy, change, flip. This first one, though, is not a fraction, which looks kind of confusing to me. But remember, we can write anything as a fraction by dividing it by 1. Because if you divide anything by 1, it doesn't change the value. So I am going to copy this first fraction now that I have it written as a fraction. I'm going to change this division to multiplication. And then I'm going to flip the second fraction. So my denominator becomes my numerator, and my numerator becomes my denominator. Now I am ready to simplify. So 2x minus 3, there's no GCF besides 1. I can't simplify that. And I can't simplify the 1. X plus 5, I also can't simplify that. But this bottom is actually a difference of squares, if we remember that from our factoring. Because 4, x squared, and 9 are all perfect squares. So the way those factor is with two binomials. We have one is plus, one is minus. And we kind of think about finding the square root of each piece. So the square root of 4x squared is 2x. And the square root of 9 is 3. So these are those two pieces we use. We get 2x plus 3 and 2x minus 3. Now that I have simplified, I can cancel. So I see I've got a 2x minus 3 and a 2x minus 3 that cancels. But it doesn't look like there's anything else. So now I'm just going to multiply across the tops and across the bottom. And I find that this is my final answer. Great job, everyone.